we've seen that in the deep learning concept of multilayer perceptron, the critical nonlinear element was the thresholding unit, which said that, if something is less than 0, it is -1. If something is greater than 0, it is 1. So this is what is giving the nonlinear behavior for the corresponding, logic. Though we actually got input from multiple inputs, ultimately the nonlinear behavior was because of the thresholding unit. So we find that the power of multilayer perceptron actually comes from its power of being able to handle nonlinearity, as we saw in the case of XOR function. It extends the power of linear separability by handling complex functions which are not necessarily linearly separable. So what happens is, the way the functions work in context of the input being transformed to output is usually the presence of a certain kind of what is known as activation function. Activation function is a crucial element of any neuron, where though there are several input nodes coming in with weights and their summation is always used along with bias, but the radical transformation in terms of the output of the neuron is dictated by the corresponding activation function. So activation function is what basically determines what the output of such a neuron will be. Like in this case, it's 1 or -1, depending upon threshold being passing one boundary or not. So what are the different activation functions which are used in the context of deep learning? So typically, deep learning will use different kinds of activation function, but the most common activation functions which are used are what is known as, basically ReLU, which is a very simple form of a nonlinear transformation where it performs a very simple function. It says that if z is less than 0, if it is less than 0, then we output 0. If z is greater than or equal to 0, output z. So ReLU of z, right? If this is z, it is plotted like this. It is 0 till here, and it becomes y equal x kind of a thing after the 0th position. So this is a very powerful nonlinear transformation function or activation function which is used for main categories of neural networks like convolutional neural networks, etc. The other more common function is what we have seen in logistic regression, where we talk about something known as sigmoid function. Sigmoid x is same as what we call as 1 by 1 plus e to the power of minus x. So the advantage of this is that this floats only between 0 and 1. So if you see, sigmoid of x is nothing but 1 by 1 plus e to the power of minus x. Sigmoid x is one very popular activation function which is used in the context of, neural networks. So what it does is it takes the output and compresses it to a value between 0 and 1. So in order for us to avoid the, bias towards only positive values, an alternative has appeared which is called tan hyperbolic x, which is related to sigmoid in some sense, but it is a slight variant which allows us to create a boundary from -1 to +1. So if you see, it is basically creating, two extremes between -1 and 1, unlike between 0 and 1 for this case. So tan hyperbolic x basically takes x and transforms it into a variable between 0 at one extreme, -1 at one extreme and 1 at the other extreme. So if you see tan hyperbolic x is basically written as e to the power of x plus e to the power minus e to the power minus x by e to the power x plus e to the power minus x. So this is basically an example where it can vary from, say, -1 at extreme minus infinity level to +1 for plus infinity level. So you can see that here. Suppose x is minus infinity, so this will become 0 and this becomes plus infinity, which is minus e to the power of plus infinity, and by e to the power of plus infinity, which is basically -1, so it goes to -1. On the other hand, if x is very high, this becomes e to the power of infinity, and this becomes 0, and this becomes e to the power of infinity, e to the power of infinity becomes close to 1. So what happens is this oscillates between 1 and -1 and is usually considered a better activation function than the classical sigmoid function, which is one way in terms of only positive. The other very simple version of transformation function which is used is the standard y equal to x, which is called a linear activation function. So in that sense, the more popular versions of activation functions which are responsible for the transformation of the output after you compute sigma of wxi plus b, which are inputs to each node in a neuron in deep learning, are the activation functions. It can be either in form of a linear function y equal to x, or it can be in form of ReLU, which is basically saying that in 0 it is 0, otherwise it behaves as a linear, or it can be sigmoid, which is saying that it's 1 by 1 plus e to the power x, or it can be a tan hyperbolic, which says that it is e to the power of x minus e to the minus x by e to the power of x plus e to the power of minus x, which is basically varying between -1 and 1. And it is these activation functions which are the secret sauce of the generalizability of the different, functions from neural network perspective, and they play a very important role.